Such a rookie mistake. Welcome back, everyone. Starting a new stream because I had Streamlabs set to output to like a mobile resolution. So if you did catch that last stream, it was really squished on the screen. So I'm really sorry about that. It should be all good now. If you like, I'm looking at the stream right now on YouTube and it looks good. So that's awesome. So let's just go ahead and get started. One of the things I thought was really neat was it looks like a question that we did before was actually promoted to a medium question. I actually managed to hunt that question down. Let me see if I can open up some previous tabs here. Yeah, it was this one. So build an array with stack operations was promoted to a medium question, which is pretty neat because now we just have like a medium question done. So if you followed along with me, pat yourself in the back. We now have a medium question done. That's at least a teaser for what's to come in the future. So with that being said, let's go ahead and resume where we left off yesterday. We're on page 3, so let's go to page 3 over here. I added some new things to the stream. I don't want to say what they are yet, but you'll see them if you see them. That's all I'm going to say. Okay, let's start from the top here. Find the distance value. Find the distance value between two arrays. So recently there's been a trend that we're starting with like low quality questions. Let's see what this one gives us right here. And let's see if that helps. Given two integer arrays R1 and R2 and the integer D, return the distance value between the two arrays. The distance value is defined as the number of elements R1I such that there is not any element R2J where R1I is less than D. So 4, 5, 8 and 10, 9, 1, 8, D equals 2. So R1 of 5, we have R2 of 8. We have this one, so there's nothing in Ri. Distance value is defined as the number of elements where Ri or Ri minus Rj is equal to 2. So you have to do 4 with every one of these, 5 with every one of these. Is that just like, is there any way to not do this? I wonder, like, if I sort this one, define number of elements, define the number of elements that t equals 2 equals 2, 2, 2, 2 is less than or equal to D. 1, 2, 3, less than, less than, less than, okay. So do we just want the ones that are, but this is, why is it 3? The distance value is defined as the number of elements R1I such that there is not any element R2J where the absolute value of Ri minus Rj, okay, so it's 2. So if I do 4 minus 10, that's 6. 4 minus 9, that's 5. Okay, 3, that's greater. 4. Okay. Here they're all greater. But this is less than, this is less than, this is less than. So why is the answer not 3? Not any element. This is a very weird, the distance value between the two arrays. 2. Less than or equal to 2, less than or equal to 2, that's 1. What is it exactly that they want me to return here? It's a very confusing question. The distance value is defined as the number of elements such that there is not any element in R2J where R1I minus R2J is less than or equal to D. So 6, 5, 3, 4, that's greater than 2. For R1, we have 5, 4, 4, 3, but R2, 8. 8 minus 10, 9, 1, 8. 8 minus 8 is 0. But these are 3 different numbers that are less. I have no idea what this question is asking me to do. So much so that I'm just going to skip it. If anyone knows what that's asking, I'd be more than happy to go back to it, but that one seems very weird. Let's go to this one, which hopefully, okay, nice. Divide a string into groups of size k. So a string S can be partitioned into groups of size k using the following procedure. The first group consists of the first k characters of the string. The second group consists of the next k characters of the string, and so on. Each character can be a part of exactly one group. For the last group, if the string does not have k characters remaining, a character fill is used to complete the group, okay? Note that the partition is done so that after removing the fill character from the last group, if it exists, and concatenating all the groups in order, the resultant string should be S. Okay, so we do A, B, C, D, E, F, G, A, I, G, H, I, okay. Here we have 3, A, B, C, D, E, F, G, H, I, J, X, X. Wait, so they just want us to do that? Can I just slice, and anytime the slice is less than, like, I can slice strings, and anytime my slice is less than, like, slice strings, if slice is less than k, then we add, like, if it's 1 and it's k, then we just add k minus 1. We add k minus length. So, I mean, is that what it is? So what if we have something like const result for let I equals 0, I less than s dot length, I plus plus, const slice equals s dot slice. We don't actually want to go, this should be plus or equals k. Okay, s dot slice of I to I plus k. If slice dot length is less than or equal, let me see, if it's less than k, we'll do something else. Result dot push slice. So if slice dot length, we can just push. Let's see. So const difference is k minus equals k minus slice dot length. I'll do this. Oh, we can actually do, actually, I wonder if do while slice dot length is less than k. Can we just do slice dot slice equals our slice and then fill? Oh, I guess we'll always end up pushing a slice anyway, so maybe we should just do this. Result dot push slice and then return result. Will something like this work? Okay, well, it worked for the first one. Let's see that last one. Doesn't like that I'm reassigning slice, of course. I'm very used to premium. That's why I keep spamming that test button. Okay, so I think we're pretty much close. I guess we can just do slice and fill. Or we can just say slice dot concat fill instead of trying to do any like fancy JXX, JXX. Okay, let's remove this here. Submit. 32.05. Let me run this again, and then we'll come up with like an analysis here. I mean, it's a pretty cool question. 50%, so there's something that we can be doing faster. Maybe I just need to see how many A, B, C, D, E, F. Anytime, so given the string S, the size of each group, it'd be nice if we can just like, I only have to add however many X's are at the end. Maybe I don't even need to do, right? We're just gonna keep, we're gonna see how many partitions we can make, right? Like here, this is the length like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We can just easily make 3 of these. Here, right, GHI is 9, 10, 11, which gives us 2. So at the end, we just add the 2. I think we can just do that. Yeah, I think I have a different solution here. So instead of doing this, we're just going to do, let's do const result equals this. I can keep doing like for let I equals 0, I less than s dot length, I plus plus. I can just say result. This should be plus or equals k. Result dot push s dot slice of I through I plus k. If, let's see, if s dot length modulo 3, if s dot length modulo 3 is not equal to 0, right, then we just get the difference, whatever the difference of that is, const diff, or maybe we can just say if s dot length not equal, like I just want to get the last one and add however many k's to it. Like, what's the best way for me to do that? I'm just wondering, like, I only want to create that if this is true. This is like a constant time operation. I don't really even have to worry about this. Let me just check something real quick on my channel. I just want to make sure, because since I've already messed up once, I just want to make sure. Okay, cool. So if s dot length modulo 3 is not equal to 0, then that means the last one needs some extra padding. How much padding? Whatever this thing ends up being. So we can do const padding equals s dot length modulo 3, right? And then for the last one, it'd be nice like if there was just a way. I wish I can like push, like if there was a method for me to just push a character some amount of times. For let I equals 0, I less than padding, I plus plus, we can say result at result dot length minus 1 dot push fill, and then here we'll just say return result. Will this work? Result is this, result dot push, okay. This is just a string, so maybe we should just do plus or equals. Doesn't like that I'm doing a push here. So 0, I plus plus 1, we add another 1. So what's s dot length modulo, oh wait, this should be modulo k. Modulo k. Anywhere I see a 3, it should be a k, okay. Let's try this out. jx, why are we only, oh, does it need to be equal? Okay, let's try this one out. Aw. I thought the difference would just be like however many partitions I can make. So this is 8, so I can go from 0 through 8 here. And then how many characters can I get from there? S dot slice. Maybe it should just be the difference of the partition size. Maybe it doesn't even need to be this, right? If there's just a difference. Yeah, you know what? I think the difference should actually be, yeah, it should be whatever the last one is. So I do 0, 1, 2, 3. I go up to the T, and I go 1, 2, 3, 4, 5, and I just add 3 more. The difference is the K minus the length. Yeah, so maybe we say if the last one, if result at result dot length minus 1, if the length of this one is not equal to k, then we need to pad, const padding equals the length of that last one. So length minus 1 dot length minus k. And here we should be able to do the same thing. I think this is the missing piece here. If we do this, let's now try, and the worst part is this will mess up my acceptance rate, but it's fine. Like, we're learning new things here, so. Will this one pass? If result at result dot length minus 1. So like, we have GHI, we have this one. Result at result dot length minus 1 is here. dot length is not equal to 3, for example. So we should actually do k minus that. It should be k minus this. Let's try that again. And now I think we can remove the equals piece. Let's try this one out. Okay, 70. So the time did get better here, right? So like pay close attention to that, because we actually did increase our time. Well, not increase, but I mean we got a better percentage. Okay, 33.33. And I would imagine maybe this one here. I mean, this is still the same thing, right? We're still pushing. I'm still pushing, and this will only happen if it's not an even string, and at most it should only happen once, right? For the last one. That's only going to happen once. Let's see what the solution is here, or the discussions rather. Division and modulo. We pre-initialize the result with filled k-size strings, then we place the ith character into the res. We fill it with that size for int I less than res of I divided by k, a modulo k equals s of I. Pre-initialize the result with filled k-size strings, then we place the ith character. The ith character? This doesn't really make any sense to me. Oh wait, let's go back to Java 2 minutes. First append the fill at the end of the string based on the length of string, and then divide. Oh, I guess you could do that first, right? You want to make it even. Yeah, I guess that's actually like the opposite way, right? We can actually start with the fill. So like how do we know if we need to fill if s.length modulo k, then we can just figure that out. Yeah, it'll probably be like very similar to what I have here, and it makes sense. Like here we're filling the strings, then doing the fill. Here we're like creating the slices, then doing the fill. Their solution is do the fill and then just split it by the slices, because once you add the extra padding, they'll all be evenly divisible rather. Cool. Let's go to the next one. Count binary substrings. Given a binary string s, return the number of non-empty substrings that have the same number of zeros and ones, and all the zeros and all the ones in these substrings are grouped consecutively. Wait a second, I think this is 1 0 1 0 1. Oh wait, 1 0 0 1 1 0 0 1. Interesting. Every time I see one of these questions now, I immediately think sliding window. I wonder if like, what if a zero represents a 1 and a 1 represents a negative 1? Like what if we had a counter? So here we have 1, and then we have 2, and then we have 1, and then we have 0. And maybe that could be like our first string. Here we have 1, we have 2, negative 1, and then 0. That's our second string. Will that work for this next one? So imagine we start here with we have a negative 1, then we have a 0. That's one string. We have a 0, but then we add this one, 1, and then we go to the next one. Okay, so I think what we have to do is like check if it's 0. I guess we can. No, we can't check if it's 0 first. We need to do the add first. So add, do the operation first, and then check for 0. I think maybe we can get away with something like this. So if I follow that, so I say do the operation first. So this is 1, this is not 0. Go to the next one. This is 2, it's not 0. Go to the next one. 1, it's not 0. Go to the next one. 0, okay, that's 0. So now we can like append this string. Cool, go to the next one. Do the operation first, this is 1. Okay, sweet. When we get here, what happens? Do the operation first, that's negative 1, that's not 0. Go to 0, do the operation first, that's 1. Okay, now here's where it gets a little bit tricky, right? Because we did the operation. We did the operation, so that's 0. But before, maybe we need to also reset. Like if we add, maybe if we do something like, if this is an add, we reset, maybe something like that. And what I mean is like, here we do the operation, that's -1 for 1, right? And we go to 0, that makes this a 0. So we add it because it's 0. But because we just added it, we should also reset the counter to whatever this is. Now it's 1. Then we go to the next one, that's -1. We add it, okay, cool. Let's see what happens here. It's a 0. Operation, not 0, we get to 2, not 0, 1, this is 1, then 0. Let's see, we just added, so do we reset to -1? If I reset to -1 and then go here, I'm going to make that 0, which I don't want. So what can we do? What can we do so that way I'm always... It says, given a binary string, return the number of non-empty binary strings. Because this has a 1 and this has a 0. These are the same number of each. Then we have a 0 and a 1. This also has the same number of each. We can also just do like, I guess sliding window can be the thing, right? Because here we have 1, 0, 2 zeros, 2 zeros and 1, 1. We have 2 zeros and 2 1s. Okay, cool. Now, what happens when we go here? Because now we have, is this, so I guess we just cut it off here and then reset. So here we have 1, 1, 1, 0. Okay, cool. Reset and add. I guess we can have a count of each. Yeah, we can have count of each 0 and 1 if they are the same. We add and reset. I'm thinking something like this. So what if we just have, let's say we have let 0 count equals 0, let 1 count equals 0, and we can say, let's say start index, or we can just say start is going to be, or maybe we have like slice start equals 0. Oh, we don't even need, okay. Let substring count equals 0. Let's do for const b of s, b because it represents like a binary digit. What can we do here? So at any point we can say if 0 count, so maybe we shouldn't do that right in the beginning, right? Because we only want to check 0 count after we do some operation. So here we say if b equals 0, 0 count plus or equals 1. If b is equal to 1, 1 count plus or equals 1. If 0 count and 1 count equals, or if 0 count equals 1 count, and we say substring count equals, or we can just say substring count plus or equals 1. See, again, before I go, right, this would be 1, 1, that's the same. Now we reset and we just add the one that we're currently on. Substring count plus or equals 1. We reset them. 0 count equals 0. 1 count equals 0. I'm going to put this again in here really quick. It's not nice. I'm very aware of the fact that this is not nice, but just bear with me here. I want to try something out. Let's see. I want to go through this string and see what we can get. So if I start at this one, so my C is here. So 0 count, if B equals 0, 0 count is 1. If B equals 1, okay. they're not the same, so go. 2, they're not the same, so we can just keep going. Here, 1, they're not the same, so keep going. Here, 2, they are the same, so we add 1 to this. We make each one of these 0. You see, and this is the tricky part. Why for this one? 0, 0. This definitely has to be a sliding window question, because this logic doesn't work here, because then I'm increasing the 1 here, but then I'm not like, I'll never get to a point where these are both the same, even though they are here. One zero one zero one 1 0. Okay, I guess as long as they're not the same, we can continue. Here they're the same, so that's fine. So we increase start and then keep going. This one's a tricky one. This is definitely, I really feel like this has to be a sliding window type of thing. If we do this, let's just make this as wide as we can. What if we have our window here, which I'll denote by drawing, I like doing the diamond thing. Like, what if this right here is going to be like the start of our window? But we can keep going as long as they're not the same. Right now we have 2 zeros and no 1s, 2 zeros and 1 1s, 2 zeros and 2 1s. Okay, that's cool. So we just do that, I guess. And I guess we keep going inwards like this. Okay, now they're both the same, but we can, like, do I just go to the next one? What happens when I get here? I just start here. Now even if I try this other one, 1 0 1 0. So I start here, both the same. Okay, come here. Cool, both the same. All right, come here. Both the same. All right, cool. Come here. Both the same. So why doesn't that work for the other one? I really want that to work for the other one, right? Like here, both the same. All right, cool. Come here. But then like, wait, is this an actual 1 0? Oh, wait a second. Why was I getting caught up in that? No, it's right. It's right. I think so. All right, we have these two, but it needs to be the same of both. 0 0 1 1. They're both the same. Okay, then we come here. Here they're both the same. All right, cool. Then we come here. Here they're both the same. All right, cool. We come here. Here they're both the same. All right, cool. Come here, and then that's it. But they said there's 6 of them. So 0 0 1 1. Then we have, oh, 0 0 1 1. Okay. Here they're exactly the same. Now why 0? Here they're also the same. That's 2. Okay. That's 3. 4. 5. 6. Okay. I think we're getting there. I think what we do is we increase. Can I make this one smaller? No. Didn't want to do that. I think here, so we have start and end pointers. Start and end pointers. We increase end until same count of 1 and 0. Right? So here, this is the first time. When they are the same, increase substring. And then increase start until equal to end, also checking for same. Like right here, boom, they're the same. No, wait, no, they're not. The same number of zeros and ones. This just gets harder and harder. I really thought it was onto something here. 0011. Like this has the same. Not the same, not the same, not the same. That's 2. Right? Because that is the same number. Not the same. Not the same, not the same. That's 3. That's the thing. We're missing this one. Substrings that occur 000101 1100. It's like they're stopping here. But before they even get there, tricky. I really need to get, if this is sliding window, I want to look at the related topic, because if it's sliding window, 2 pointers and string. Okay, well, it's 2 pointers, okay, but it's not, it doesn't have to do with sliding window, because this is the same. But then, like, do I just always... That's so weird. If I start from here, how many have... Yeah, this one's really tricky. 0011, 2 pointers and a string. 6 substrings that have equal number of consecutive ones and zeros. 0011, 01. Notice that some of these substrings repeat and are counted the number of times they occur. What have we used before that we can use to solve this? A 2-pointer technique. I just need to go through and count. I mean, what if we had, maybe not frequencies, but it's like every single substring, right? Because a substring, it could be like all these, like, I mean, there's a brute force thing that we can do, right? We can check every single substring, like all these, right? And then we start here, we check all these, so on and so forth. Not the best way to do it. There's definitely a faster way to do it. We need to save, like, 0001, and we come here, calculate all these. I mean, it is 2 pointers, right? We're using 2 pointers to do it. I know it's not that, though. Let me see. Let substrings equal 0. For let I equals 0, I less than s dot length, I plus plus. For let j equals I plus 1, j less than s dot length, j plus plus. Let's see. Let 0 count equals 0. Let 1 count equals 0. If, let's see, which one do I actually want to keep track of, though? If the amount of 0 counts and 1 count, but I haven't even counted that first one yet. Am I really going to have to do like 2 counts? That seems bogus. I think I might save this one for a weekly roundup. This one's proving to be way more tricky. I want to like take time to like really dig into this one on a whiteboard or something and figure it out. So we'll try and get back to that one. Special positions in a binary matrix. Given an m by m matrix mat, return the number of special positions in mat. A position a position ij is called special if mat ij equals 1 and all other elements in row I and column j are 0. Rows and columns are 0 index. 10001. So what is it again? It's called special if and all their elements in row I and column J are zeros. Oh, this is very good too. I think really all we need to do, so it's only if it's like isolated on the row and the column. So I think we should just, one easy thing that I can think of is we can first go through this and keep track of where all the zeros are. We can have like a map of rows and columns. So something like, let's see, if it's the only one, all other elements in row I and column J are zeros. So there shouldn't be any ones in this row or column, right? So let's say, obviously my dog is a little bit upset right now. He's upset because we're doing this question. That's why my dog's barking, because he doesn't like this question. No, it's good though. Let's say const col const row. We can say for let row equals 0, row less than mat dot length, row plus plus. For let column equals 0, column less than mat of row dot length, column plus plus. So we want to say if mat of row column is equal to 1. Let's see, we can say if, I guess we can say column, no, this should be col map and row map. If column map at column, or I guess we can just say true, right? If it's a 1, then we'll just say col map of col equals true, and then row map of row equals true. So here we'll just have like column of 0 equals true, because that means there is 1 in here, right? And then column row. But now here, for example, column, there's 3, even though, yeah, this will always be column 1, right? So if I get to column 1, if it's true, that's okay. Yeah, column map column and row map row true. Okay, so I think now what we can do is we essentially just do the same thing again. We can say let special equals 0. Let's copy this bad boy again. We'll come through here. Now we say if mat row of column equals 0 or equals 1, and we can say column map of col equals undefined, and I'll tell you why I'm using undefined in a moment. Let me just make some new lines here to make it easier to read. And row map of row is equal to undefined. We can say special plus or equals 1. And then we'll just return special. So will this work? Defined and defined. Let's see if this one. 0 and 1. Okay, let's see what's happening here. So mat row of column, if it equals to 1, and this failed in the first one, 1 0 0 0 0 1 1 0 0. So let's see here. I'm saying there's a row, like row map of 0 is true. If mat row column equals 1, there is a 1 on row 0. There's also a 1 on column 0. Then I get to here. This is, oh, I see, okay. But I don't also, I guess it should be the only one on that one. It's not so much that there's, yeah, I see. This is a communication issue here. Didn't read it thoroughly enough. Let's think about this again. Because in this case, yeah, I set that already equal to true, so I would only want it to be, can I just keep track of the count? If it's equal to 1, we could also say, let's see, in this first one, let's just keep track of the frequency of the ones. Here we can say call map plus 1 or 1. Here we'll do row map plus 1 or 1. So if it's equal to 1 and this is 1 and this is 1, right? So what would this look like now? We get to mat row of column, so row 1, column 2. And this should be less than or equal to 1. And less than or equal to 1, because it also could be 0. Here we'll say like column map, so column 2. Is there anything on column 2? No, it's less than or equal to 1. On row map, less than or equal to 1. Here, well, here's the same story. So 1 and 1. Let me just refresh this. One and three, let's rerun it. 13.42, that's interesting. The reason, so this solution that I used is very similar to another one that we'll do later on. It's a medium, it's called set matrix zeros, I believe. Okay, 82.93. Let me see what discussions have to say. Because can we, two classes, okay. There you go. Count number of ones, and for each one, check if it's alone. All right, copycat question. I'm wondering why that question is medium and this one easy. Does it mean that we getting better at this as a community? Yes, we are. That's awesome. Okay, cool. So yeah, it's a very similar style question to like other ones. So if you understand this one, then you're in good hands. Okay, cool. Let's go to the next one. So check whether two strings are almost equal, almost equivalent. Two strings word 1 and word 2 are considered almost equivalent if the differences between the frequencies of each letter from A through Z between word 1 and word 2 is at most 3. Given two strings, the frequency of letter X, okay, there are 4 A's in A, but 0 A's in B. The difference is 4, which is more than the allowed 3. I think what we can do, yeah, we can create an alphabet. I think we can have like alphabet 1 equals new array of 26.fill 0. We can also have alphabet 2 equals new array of 26.fill 0. For each one, we can say calculate frequency. Right, so here we'll take an alphabet and here we'll take a word. What we'll do is we'll say for const c of word, we'll get the index c.carcode at 0, and then we'll say alphabet of index plus or equals 1. We can do this twice. Here we'll pass in alphabet 1 and word 1. Calculate frequency of alphabet 2, word 2, and now we can just say return alphabet 1 dot every. Now here we'll run a method on every single element in an array, and it'll actually end early for us as soon as it returns false, which is nice. So we get the element, index, and the array. So here we can say frequency, element, index, and array. So frequency and index. Here we can actually say we want the difference between the two frequencies. So we want to return if math.abs of frequency minus alphabet 2 of this index, math.abs of the current frequency of alphabet 1 minus alphabet 2 at the current index, if that's less than or equal to, so that's if it's at most 3, just more, the difference is 4, so it needs to be less than or equal to 3. Return math.abs, and I guess we can make this a little bit cleaner here. We'll remove this, and we can also remove this. less than or equal to 3. This one corresponds to that one. So I feel good about this. Let's see. False and false. Let's come to the next one. False, false, false. Okay, definitely something going wrong here. I might not be able to index. Let's see. So the math.abs of the frequency. So calculate frequency, alphabet 1, alphabet 2, of word 1, word 2. Const of word, const index, of course. We did not. We have to subtract 97 so that we can map a lowercase a to 0, b to 1, etc., etc. Let's see. False, true, true, false, true, true. Let's submit this. 98.13. Feel really good about this one. Yeah, this is a very nice question. Let me see. I think I do like the one that we did before, so I'm gonna like this one. I'm also gonna like this one. This one's really, really great. This one's very cool. Yeah, so we just calculate the frequency of both, and then we just get the difference of every single position. Let's look at some of the highest voted ones. C++, straightforward. Return false. Yep, that's exactly what we did. Counter arithmetic. Okay, well, this is some crazy stuff. I see, like me, I really prefer this one. Yep, O of n time and space is constant. Actually, for const C of S, and yeah, it's linear. Sweet, yeah, that sounds pretty cool to me. Let's see, special positions. Okay, design hash map. We had a hash set, now we're going to do a hash map. Design a hash map without using any built-in hash table libraries. My hash map initializes the object with an empty map. Void put enters a key value parent to the hash map. If the key already exists in the map, update the corresponding value. Returns the value to which the specified key is mapped, or 1. Remove. You see, like, without using any built-in hash table libraries, because this is weird. And I'm saying it's only weird because, like, I can't use an object literal. So there was one we did before that was like a hash set, and the question actually wanted us to like design our own hash function to be able to put it inside of like the specific key. Yeah, like I'm not sure if that's what it wants us to do. I'm gonna look at this real quick. Related topics. You see like hash function, linked list, hash table. I think it wants us to create our own. Initializes the object with an empty map. Void put enters a key value parent to the hash map. Update the corresponding value. Int get returns the value to which the specified key. Void remove key removes the key and its corresponding value if the map contains the mapping for the key. Yeah, I think it wants us to design a hash set where we actually have to generate a key. I suppose we have to enters a key value parent to the hash map, update the corresponding value. Map contains no mapping for key. I really, you know what? Because at the sake, is that even say it? At the expense? There's a word I'm looking for, but I'm gonna go straight to discussion because I want to see if it doesn't want me to like. Okay. Right, and it wants okay. So yeah, it really wants us to hash with chaining. Okay, I think what I'm gonna do myself before I even solve this question, I'm gonna remind myself of all these different things. I did these things in university, and I remember some of like linear probing methods and the other ways of generating hash keys, but I think it's worth it for me to actually revisit how to do all that and then come here and implement it. That way I do it once, I implement it, get the practice, and that's just going to make it a lot better for me. So let me just go to the next one because I don't want to do this like the easy way. Okay, consider all leaves of a binary tree from left to right order. The values of those leaves form a leaf value sequence. What? For example, in the given tree above, the leaf values, okay, two binary trees if their value sequence is the same. Return true if and only if the two given trees with head nodes, root 1 and root 2 are leaf similar. Can we just compare? If I just do like, I mean, it'd be nice if like anytime I find a leaf node, I just return true, and then I return the and of all that. But what do I do when it's just like return? I come over here, I go left. Okay, that's my base case. I guess I can have one with only one child. I wish there was an example like that. That's my base case. I come here, I don't go right. Okay. Only when both, oh, but they're not going to be the same tree though. They're not going to be the same tree. So 1, 2, 3. Are they going to be number of nodes? No, this is a contrived example because the trees are the same. I think what we should do, we can generate all, I don't want to do this because like the most ideal thing would be to stop as soon as I notice that they're not, how do I say this? As soon as I notice that they're not the same, we can stop. But I'll only know that after I've gotten all the leaves. So it almost forces me to go through this entire tree. Well, let's figure it out. Like, let's say const get leaf nodes. This will take a root and leaf nodes. And now we'll just start traversing. All right, we'll say if root, can do get leaf nodes root dot left. Or I guess here we should just say if. We can say if root, if not root dot left and not root dot right. We'll say leaf nodes dot push root dot val. Okay, here we'll say if not root, we'll just return, and then we can say leaf similar root 1 or root dot left, leaf similar root dot right. Okay, if not root return, we'll just go to the next one, go to the next one. I guess I can also do this one at the end. So let me do this. Let's do that. Leaf nodes dot push. So I'll say root 1 leaves equals get leaf nodes of root 1. Leaf nodes dot push val. Let's also return leaf nodes here. Let's do this. Let's set a default parameter of an empty array there. We'll do the same thing for this next one. Const root 2 leaves equals get leaf nodes of root 2. And now we can just compare them. Now, I guess they need to be, okay, so return true, are leaf similar if their leaf value sequence is the same. Okay, so we can say if root 1 leaves dot length is not equal to root 2 leaves dot length, then we can return false. Else we should just start going for let I equals 0, I less than root 1 leaves dot length, I plus plus. If root 1 leaves of I is not equal to root 2 leaves of I, return false. And finally, we can return true. So what I did is I'm getting the leaf nodes for both roots. If they're not the same length, they can't be similar. And then we just go through each one of them, comparing each value. If either one of those are not the same, we return false, and finally we return true. See what this gives us. So here, let's see, what does it not like? Return leaf nodes. Oh, let's do this. Root1 leaves dot length. Why doesn't it like that? Cannot read properties of undefined. Root1 leaves, root1 leaves. We pass in this, return leaf nodes. Yeah, wait a second. Get leaf nodes, get leaf nodes. Here, I should also pass leaf nodes. Here, we should pass in leaf nodes. Let's try this again. Did I do, nope. Did I do the same thing here? Leaf nodes, push. Let's make sure we're actually getting console.log root1 leaves, root2 leaves. Circular, circular, your input and std out. Nope, should not do that. Leaf nodes.push, get leaf nodes.push root.val. Let's try this again. A lot of little mistakes I made here. I was trying to go through this one like way too fast. Okay, that looks fine. Let's run this next one. True, false, let's submit. 78.66. So if we think about time complexity here, now how is it that we can, like, I know there's a formula to, what is the formula for like how many leaf nodes are in a tree? I guess we'd have to know the height first. Like formula to get leaf nodes in a tree. Formula for amount of leaf nodes in a tree. Is that even a thing? Determine the count of leaf nodes in an n-ary tree. How do you calculate leaf nodes in a tree? If a root is leaf node, return 1. Okay. To count leaf node, number of leaf nodes in a full binary tree. The number of leaf nodes in a full binary tree with n nodes. I guess we need to have the amount of nodes too, so we don't really know, but like get leaf nodes, this is going to run twice, and that's going to go through every single node in this tree. So this will be like O of m plus n, where m is the amount of nodes in root 1 and n is the amount of nodes in root 2. And this piece right here is going to run in some n time, where n is the amount of leaf nodes, not this, I'm sorry, this right here. So it's like O of m plus n plus some other number that I'm not really sure how to express, but it's just going to be the amount of leaf nodes in the tree. Submit this again, 78.66. What is the solution? Depth first search. Yeah, find the leaf value for both, okay. Yeah, T1 plus 2, the lengths of the given trees, the space. Oh, I guess, you know what? Yeah, that's the thing. That's the bottleneck, right? So that's what it ends up being. More intuitive way to think about it is an order traversal of both trees. Okay, cool. Let's see. We have about a minute left. Let's see if we can do this one quickly. Calculate money in LeetCode bank. Hersey wants to save money for his first car. He puts money in the LeetCode bank every day. He starts by putting in $1 on Monday, the first day. Every day from Tuesday to Sunday, he will put in one more than before. On every subsequent Monday, he will put in one more than the previous Monday. Okay. So, I mean, isn't that still just like one every single day? Isn't that just the count? After the 10th day, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. Notice that on the second Monday, Hersey only puts in 2. Oh, he starts again every single, okay. Plus 3 plus 4. After the 20th day is 1 plus 2 plus 3 plus 4. Oh, this looks like a really nice, like, not like a, yeah, it's almost like recursive maybe. Oh, I would really like to solve this. You know what? I think maybe we can just do this with DP. maybe, but also maybe not, right? Because the first day, let's see, we have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, Monday. Okay, so every time we get to a number, well, I can also just start on 0 and make that a lot easier for me. So I'll increase 1 unless I get to, yeah, we can have like, let previous amount equals 0, let total equals 0. Here we can do for let I equals to 0, I less than n, I plus plus, let's see, if 7, if not 7, if I modulo 0, if I modulo 7 is equal to 0, and let me just, I know that sounds crazy, but like, is 0 modulo 7? That's 0, right? Okay, cool. And 14 modulo 7, yeah, we know that's 0. Okay. If I modulo 7 equals 0, then we do total plus or equals, let's see, we should do previous plus or equals 1, total plus or equals previous, else total plus or equals 1. Maybe. 1, 2, 3, 4, 5, 6, 7. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Monday, Tuesday. Notice that on the second day, Hersey only puts, okay. So he's adding 2, but it's always changing from the time before. Maybe we just always add 1 plus 2 plus 3 plus 4. We'll just add, so like previous will equal 1, and then we'll just add, will the total just be total plus or equals previous? I'm getting mixed up in this. Frankly, it's Friday, and this, I feel like this is an easy question. I don't think it's very difficult, but my mind's a little bit fried from the workday, so I actually think I'm going to end it here. But I do appreciate everyone for tagging along. I hope you all have a great weekend. Tomorrow, stick around. We're going to do our weekly roundup, so we'll be able to revisit some of the questions that we didn't get a chance to finish throughout this past week. So I hope to see you all again tomorrow for the stream, and happy coding. Have a great rest of your week.